Hello, hello, chemistry students. Welcome, welcome. This is the second video in the simple stoichiometry series. This video, we're going over simple one-step problems. The next one will be a couple more practice problems. And then after that, I'll have another one that is talking about two-step problems. And that is, from there, we'll be kind of jumping off into real stoichiometry. So at this point, we're going to do the practice problem 1. This is the one that we did together in class. My cursor is in the right spot, so let's go ahead and highlight this. Now, in case you cannot read it, feel free to go back and replay this part if you need to. How many molecules are there in 2.00 moles of potassium chlorate? So that's what we have to actually answer. And to do that, we're going to use the conversion web that I just realized I forgot to write about here. So I'm going to do that real quick, and then we'll actually solve this problem. So pardon me a moment. All right, so hopefully that one is a little easier to read than the one that was in the giant picture. So this is a little less blurry, so I hope that's a little easier to read. So the first thing we have to determine in this question is what our known is. Now, the known is the information that is given in the question. So it usually is going to start with a number and go through a formula. There are 3 pieces you have to have in your known and in your final answer, whatever it may be. You need a number, a unit, and a formula. So here we have a number, 2.00. Here we have our unit, moles, and here we have a name, which we will turn into the third, our formula. Using the stuff that we talked about way back when, that we have been practicing for most of this semester, the beginning of this semester, we need to turn this name into a formula so that we can actually, write it, because we're going to need it for things later on. So first off, this is what? Potassium chloride. So potassium is a +1 charge. Chloride is a -1 charge. So KCl is going to be the formula because it just cancels. So you need to draw a line. Now I have a line here. It's a little faint, so I'm going to go ahead and go over it with a marker. This line is what we are going to build our conversion table around. Get it straight here. There we go. So this line is going to be the basis for our conversion table. At the beginning of the line, we are going to put our known. Then we're going to write all 3 parts. So we start with 2.00 moles, and, oh, that is chlorate. I can't read, apparently. I can't read backwards. That is chlorate. So this is not KCl. This is KClO3. So I get for trying to read backwards. Okay, so this is our known. Now this is a fraction because it is over 1. And everything we put into this table is going to be a fraction of one kind or another. Now there are no units in this denominator, which is a good thing, because when there's units in the denominator, the conversion web or conversion table gets a little more complicated. So this is a good thing. Now at the end of our known, we're going to put a vertical black line. That vertical line says this is the end of the first fraction. In the next section, we're going to write our second fraction. Now, the known always goes at the beginning, and then the fractions that you add have to come off of here. So the known has to be one of the 3 black things in this table, either the mass, the moles, or the number of items. So the first question is, what is our known? What is the known on this? Well, it has units of moles, so it's N. We have units of moles, so that makes this N. Then what is it asking us to find? It wants how many molecules. So if we're looking for molecules, then we're trying to get to items. We're going from N to items. Between n and items is Avogadro's number, Na. So that is what we have to use in order to solve this problem. So on the back side of your periodic table, the one that I provided in class and that I gave everybody a hard copy of, it's not laminated, but you get a hard copy of it. Here is a box labeled Unit 4. Okay, here at the top is the conversion web, color-coded if you're using the laminated version that's in class. If you're using one of the printouts, it's black and white because I couldn't do the color coding. Underneath that, though, is the important thing. So here is the equation for molar mass, and here is the equation for Avogadro's number. Now, when you actually enter these into the table here, they need to be in this format. Okay, so we are going to use Avogadro's number here for the first one. So we're going to start by putting 6.022 E23. I'm going to write that above the table because there's a chance we might have to flip this over. So you should always jot it down first out of the table and then add it to the table after you have the entire fraction written out. So we start with 6.022 E23. And then the next thing on here says items. Now, items is always going to be either molecules or atoms. You do not actually write items. You write either molecules or atoms. In this case, it told us in the question, we want molecules. So I'm going to write, after Avogadro's number, instead of writing atoms, I'm writing molecules. And then the last thing it says, it's in like little braces here. You don't need the braces, but is formula. Now the formula here is the formula for this specific problem. So for us, the compound we're working with is potassium chlorate. So the formula that we're going to put here is potassium chlorate. KClO3. And then all of that is the numerator. And it's over our denominator here. Raise it up, doll. Come on. All right. That is over our denominator, which is 1 mole of the same formula. So we use the same formula again here. So our denominator is 1 mole of KClO3. That is the fraction that needs to go into the table. Now, problem is, sometimes this fraction goes in right side up, sometimes this fraction goes in upside down, meaning the 1 mole KClO3 goes on the top, and the 6.022 E23 molecules of KClO3 winds up on the bottom. To figure out whether you have to flip the fraction or not, you have to look at the units and the formula that you started with. Okay? So here's a little trick that you probably saw at some point in either middle school or algebra. So if I take 2/3 times 3, what does that give me? Well, that's going to give me 2. I know that's going to give me 2. Without doing any math, I know that's going to give me 2. Because I have a 3 in the numerator of this fraction and a 3 in the denominator of this fraction. So rather than going, well, that's 6/3, which reduces to 2, I can go, oh, well, those cancel, which gives me 2/1, and we don't really have to write the 1, so it's 2. This is what we are going to be doing here, except instead of doing it with the numbers, we are going to do it with our units. So we currently have moles of KClO3 in the units on our numerator. We need this unit right here to cancel out with whatever we put here. Okay, we need this to cancel whatever goes in as the next fraction. So if we look, the numerator on this is molecules of KClO3. The denominator is moles of KClO3. So we need the moles of KClO3 to cancel with this. So this has to be in the denominator when we rewrite it. So we don't have to flip this fraction. We just bring it straight down. So 6.022 E23 molecules of KClO3, and that is over 1 mole KClO3. Then, after you have written a fraction, this is any time you add something here, you put a vertical line to mark the end of this fraction. Now we cancel what cancels. So the moles of KClO3, not the 2.00, just the units, moles and formula KClO3, cancel with this moles of KClO3. And that leaves us now with molecules of KClO3, which is what we want. How many molecules is what we were told to find. So these are the units that we need in our answer. That means we're done building our table. This is a one-step problem, so we only need one step to solve it. So now we put equal signs over here, one for the top, one for the bottom. In this particular problem, the bottom is 1 times 1, so that's not too bad. The denominator is going to be 1. But then to get the numerator, you have to take this number times this number. So 2.00 times 6.0022 E23, which comes out to 12.044 E23. Now, if you type that into your calculator, I'll tell you it's going to give you a slightly different answer. It's going to tell you 1.2044 E24. Those two numbers are the same number. Technically, with scientific notation, you're only supposed to have one number on this side of the decimal point. So 12 is technically wrong. It's not the right way to write it. You should be writing 1.2. I can do this part. I can get this in my head. This takes a little more work. I don't care which one you put, as long as you end up with the right answer. Now, if your calculator spits this out and you've got an issue of like one decimal point, and this number is wrong, that's probably what it is. If you typed it into the calculator, I probably just didn't. And so my key has things just shifted just slightly. It should say or on the answer if that comes up, but sometimes it may not. So that is our number. And then with that, we also have to put whatever is in this red box here, molecules of KClO3. So molecules KClO3. But that is not our final answer. And the reason it is not our final answer is because of sig figs, our old friend. When we first introduced molar mass, we talked about sig figs. So we cannot have more digits in our answer than the fewest number of digits we had when we calculated. So we have a 3-digit number here and a 4-digit number here, which means we cannot have more than 3 digits in our answer. So we need to round this at the 3rd digit. 4 does not change the 0, so our actual final answer is going to be 12.0 E23, because this is outside of the sig figs. This means times 10 to the 23rd, so we need to keep that. Molecules of KClO3. And that is your actual final answer. Now, that was probably really fast, and I would encourage you to go back and take another look at it. I'm going to step off screen, prep the next one, and we're going to do one more practice problem together in this video before we go on to the next one. So, I will be right back. All right. So this is problem number 2, again off of worksheet 4.1. I'm going to read this because I know it's a little blurry. This one is, if I have 2.56 G, or grams, of lithium hydroxide, how many moles do I have? And here you'll see moles is this time written with the E in it rather than just MOLS, as I said you would occasionally see. So if I have 2.56 grams of lithium hydroxide, how many moles do I have? So this time, our known is the man, this line's in a bad spot. Okay, we have 2.56 grams of lithium hydroxide. So we are starting here at the M, and we are looking for how many moles. So we're going here to the N. So we're going from mass to moles, or M to N. So this time, molar mass is what we use in order to cross, or what we're crossing to actually calculate it. So first, before I get too far ahead of myself, let's write down our known. Now, I'm not going to draw the line this time because you guys can see it, and it was kind of annoying having that there. So I'm just going to not draw it. You can see it well enough. So I'm going to write down the known here, which is the 2.56 grams of lithium hydroxide. So that's going to be 2.56 GLiOH. And then right after that, I'm going to put a vertical line to signify the end of the known. Now again, you can put the 1 underneath if you need to help you keep things straight, but it is not required. Okay, and now we need our actual step, our conversion factor, the the blue numbers here, and the molar mass in Avogadro's number. We need to actually calculate our conversion factor for this problem, because this time our conversion factor is the molar mass. And the molar mass is not, well, you could look it up, but you're going to have to actually calculate it most of the time for this class. So to do that, quick little refresher, we make a list of our values. So we have lithium hydroxide, which is L, I, O, and H. So we have 3 different elements. Am I in the way here? No, I think I'm good. Okay. L, I, O, and H. Lithium is 1. Oxygen is 1. H is 1 because we have 1 of each in this formula. We don't have 2 or 3 or 25 of any of them, so this number is just 1. We take that times the molar mass of the element, which you find on your trusty periodic table. Specifically written, there's a J on that. That's probably actually a hangman. Oh, well. You find on your periodic table, it's the red number at the bottom of the cell, the average atomic mass. So for lithium, door's in the way. For lithium, that is going to be 6.914. For oxygen, that is 15.9994. And for hydrogen, that is 1.00795. Now, normally, you would then go equals, 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 and calculate whatever this is times that. Since these are all ones this time, I'm going to skip that part and just add them up. Because we don't have to worry about sig figs in this if we didn't actually do any calculations. So we just add those up. So we've got 5, 3, bring the 1 up, and stop talking this out and just do it. And I'm not terribly confident, so I'm actually going to grab a calculator and make sure I did that right. I did not do that right. I messed something up. Erase that. I think I got my numbers misaligned. So that is actually 94835. And now we have to ask ourselves, because we have hit equals on a calculator, now we have to actually ask ourselves, is that the right number of digits? There we go, there's the angle. Did I do that right? Is that the actual number I'm using? Or do I have to round it? Well, we have 4 digits, 6 digits, 6 digits, which means the answer can only have 4, because this number cannot have more digits than the smallest of these 3. So between 6, 6, and 4, we can only have 4. So this is going to be our last digit. The 8 makes the 4 here become a 5. And now we are ready to write our fraction, like we did up here with Avogadro's number just a moment ago, except this time we're using the top part on this. This time we are after the molar mass. So you see this little pound sign or hashtag or tic-tac-toe or whatever the heck you're going to call it. This is that number that we just calculated. That is the number that goes on the number sign here. So I'm going to write that first. 24.95. Next on here is G, or grams, of the formula. So grams of lithium hydroxide, LiOH. All of that over, once again, it is in fact the same thing, over 1 mole of the formula. So over 1 mole of lithium hydroxide. And then we have to ask, does that go in right side up or does it go in upside down? Well, we have grams of lithium hydroxide here. So we need grams of lithium hydroxide to be on the bottom. Well, it's in the numerator the way this is written, so we do in fact have to flip this when we enter it. The 24 has to go on the bottom this time so that grams of lithium hydroxide can cancel. And then the moles, the 1 mole of LiOH goes on the top. Put a line to indicate the end of the fraction, and then we cancel grams of lithium hydroxide with grams of lithium hydroxide, which leaves us now with moles of lithium hydroxide. So we ask, are moles of lithium hydroxide what I want? Is that the answer that I am after? And if we look back at the question, it says here, how many moles? So yes, we're in moles. Moles is what we want. So we are ready to actually solve this. So we put our equal signs and we multiply. Multiply across the top. 200, not 200. That's a 2 with a decimal point. 2.56 times 1 is 2.56. 1 times 24.95 is 24.95. Then we divide those two, and that is going to give us a number. That is going to give us 0.1026051, to which we add the units that are in this red box. So moles of lithium hydroxide. But that is not our final answer, because again, sig figs. We have to make sure we're keeping the correct number of digits. So we have 3 digits in this number, 4 digits in this number, so this number cannot have more than 3. Leading 0 here does not count, not a sig fig. So we are going to stop here. The 6 here is going to make that 2 become a 3. So our final answer is 0.103 grams, no, not grams, what am I doing? Moles of lithium hydroxide. And that is the answer for question 2. on the worksheet. I'm going to stop this video here because I'm at a half an hour almost. So this is the answer or the work for problem question 2 on worksheet 4.1. Next, in the next video, I'm going to do problems 3 and 4, and I'm going to assign you to find the answer to question 5. So we'll do 3 and 4 together in the next video, which means this is where I am going to bid you adieu. Have a wonderful day. I'll see you in somewhere between a couple seconds and 10 or 15 days, I guess. I don't know. Depends on when you decide to watch it. Bye.